Vanakkam. Welcome to this course on biomedical instrumentation.
The previous set of videos, we are looking at respiratory measurements. In particular, we looked at spirometry and pneumotachometers. The previous video, we looked at pneumotachometers and plethysmograph. Starting with this video, we take a different road. From this video onwards, we will look at cardiac performance. So in this video, we look at cardiac output, measurement of cardiac output, and how cardiac output is related to blood pressure. Turns out the blood pressure is an indirect measure. We have spoken a lot in good detail about blood pressure and measurement of blood pressure. Something that we have spoken in one of the previous weeks, I think last week. Critically, one more time, I have to emphasize here, I don't have the time to discuss about the cardiac physiology. So I request you to invest some time and learn the cardiac physiology that is required for your understanding of this topic. So, because I'm going to assume some knowledge and then I'm going to proceed as if you know. And if you are finding it challenging, I request you to update your understanding of cardiac physiology. Right? So with that out of the way, let's continue with our discussion on cardiac output. Now, what is cardiac output? Cardiac output essentially is the total output of blood that gets pumped per unit time. How do you measure this? Let's say I know on an average the amount of volume pumped by amount of blood that is pumped by, say, the left ventricle is, say, X ml. How much is this? Does anybody know? Have you heard of this? From your knowledge of physiology, what is the amount of blood that is pumped by your left ventricle? Systemic circulation. Right ventricle to pulmonary circulation, whatever. The amount of blood that is pumped per beat, per one contraction of the heart, how much blood is pumped in a typical adult heart, healthy adult heart, how much blood is being pumped? You know, easy expected question in cardiac physiology. If you don't know this, you have to pause the video and check and update your understanding of cardiac physiology. Turns out that this is about 70 or 80 ml of blood per beat, per contraction. But then you also know that your heart at rest beats how many times? At rest, if you are at rest, your heart beats about, in a typical healthy adult, about 72 beats per minute, 70-75 beats per minute. Then compute the amount of blood that is getting pumped per minute. How to compute that? It is essentially the product of the stroke volume. Stroke volume is the amount of blood that gets pumped per beat times the heart rate, the number of beats per minute. Then you will essentially get the total volume that happens per minute. And usually, this is of the order of 4 to 6 or 8 liters per minute. Note that this varies as a function of health. If you are say an athlete, then you literally have a big heart. You say, you have a big heart. The athletes actually have a big heart. Now, quite literally, they have a big heart. Their heart itself actually big. That they require a smaller number of beats per minute to send, because their heart volumes are bigger. No, so understand that there are differences. It's a function of your health, cardiovascular health. It depends on many factors: your age, your cardiovascular health, and many such factors. So, athletes, for example, their cardiac output may be as high as 20 to 30, maybe in sometimes more than 30 liters per minute. That's a lot of blood. 30 liters of blood getting published. Imagine, if you can understand, just try to do this exercise. Take a 1 liter mug at your home and measure 30 liters of water in your bucket. That is the amount of blood that is being pumped in, high-end athletes per minute. Imagine how much that would be. Try to understand this volume. How would it look like? 30 liters of blood. How will it look like? And of course, that is not in your case. That is not in our case. In our case, it's about 6 to 8 liters. Even that's a large amount. You will realize how hard your heart is working for your understanding. Anyhow, if you recall your cardiac physiology, how is the heart pumping? So there are 4 valves. You know these valves. These are the mitral valve, tricuspid valve. Mitral valve. What is the other name for mitral valve? It's a bicuspid valve. Then there are 2 other valves. That is the aortic valve and the pulmonary valve. Aortic valve, and and it is critical for you to understand the pressure differences and flow. This course, I expect you to understand this. That is, at what point the aortic valve will open, and at what point the aortic valve will close. At what point the bicuspid and the tricuspid valve will open, and at what point they will close. Beyond the scope of this course for me to to teach this. Already we are out of time. And for the purpose of this course, you can ignore the coronary arteries. No, actually, they are very important arteries. But here we are focused on the cardiac output, the amount of blood that is, for the purpose of this discussion, the amount of blood that aorta is pumping out into the systemic circulation is what is of interest for us. For example, right? For example, right? Essentially, the amount of volume of blood that the heart ejects into the aorta. But then what about the blood that is getting sent to the pulmonary artery? Which one is doing that? See, if you recall your cardiac physiology, the deoxygenated blood enters the right atrium and enters the right ventricle. And through the right ventricle, when the heart contracts, the right ventricle contracts, and the right ventricle essentially pumps the blood through the pulmonary artery into the pulmonary system. That is not of interest for this discussion. We are interested in the amount of blood that gets pumped through the aorta. Where is the aorta getting the blood from? From the left. First, the oxygenated blood enters the left atrium, and from the left atrium it goes to the right atrium. There is a valve in between. What is the point at which that will happen? You will have to find out. And then this valve closes, and then the contraction happens. When the contraction happens, because the valve is a one directional, the pressure in the left ventricle is so much higher than that in the aorta, that at some point the aortic valve will open and blood will rush out. How much blood goes out through the aorta is of interest for this discussion. This is a critical measure of performance of the heart. Essentially influences how well oxygen is supplied to tissues. I already mentioned in one of the previous videos that the heart is not simply a pump. It is essentially the machine that is going to give nutrition and oxygen to all the cells in the body. Every cell in the body needs blood for 2 reasons. One is for nutrition, the other is for oxygenation. By the way, they also remove blood, also receives metabolic waste and carbon dioxide from the cells, and then those are getting cleaned up through the carbon dioxide, through the pulmonary circulation, lung function, which we discussed previously. So if your cardiac output reduces, that essentially is a function that essentially may lead to low blood pressure, inadequate oxygenation, poor oxygenation. When that happens, you know what it will cause? Essentially, it will lead to a situation in which carbon dioxide will build up in your system. This is what happens. This is a common complication with recall our time with COVID. Common complication with COVID. Right? As carbon dioxide builds up, your blood will become more and more acidic. It will lead to acidosis. It's beyond the scope of this course for me to discuss the physiology behind how the buildup of excess carbon dioxide in blood causes acidosis. And that causes shock and multiple organ failures, which essentially leads to death. This is what is the process through which this happens. When more and more carbon dioxide builds up in the blood, it's a long, it's like a 2-3 hour physiology class for me to discuss that. It's beyond the scope of this course. So please do check why this is the case. Why will, excess carbon dioxide buildup in blood will cause acidosis? There is a name for this. There's a physiological name for that. What is the name for this process? That's not simply called acidosis. There's a name for this process. Find out what it is and learn for yourself. Okay. So the stroke volume is about 70 to 100 ml for one heartbeat while at rest. By the way, this will change as you are exercising or this. So there are many ways in which I can measure. Of course, the flow sensors. I could put an electromagnetic flow sensor inside and measure near the aorta. Well, but that means that I have to open up or find a way to invasively this. The other is the fixed approach. This approach, we'll discuss the detail of how this works. This essentially computes the oxygen consumption divided by the arteriovenous difference in oxygen. If I can measure VO2, the amount of oxygen that is consumed, and the amount of oxygen in the veins and the amount of oxygen in the arteries, I could essentially compute the flow, right? That is essentially VO2 divided by the arteriovenous. This is called the fixed approach. But more often, the typical approach, the minimally invasive approach, is the so-called dilution method, the indicator dilution method. This is more frequently used. Right? So we know what is cardiac output. Just to remind, the cardiac output is essentially the product of stroke volume times heart rate. So how much blood is getting how much blood is getting pushed or pumped in one stroke times the number of times the heart beats per minute per unit time. Right? This essentially indicates the total amount of blood that is getting pumped by the heart per minute or per unit time, whatever unit of time. Then you could measure the mean arterial pressure, which is essentially the product of the cardiac output times the systemic vascular resistance, the total vascular resistance, plus some venous pressure. Recall how you can find the central venous pressure? Long time ago, not too long ago actually, one of the previous videos we saw, where would you measure the central venous pressure? Where would you measure the central venous pressure? What is the reference point? In our first class on pressure measurement, I mentioned this. What is the reference point for you to measure this? We mentioned this. If you don't recall, it is time for you to stop this video and go back to that video and find out what it is. It's at the level of the right atrium. It is at the level of the right atrium, but I have still not told you where it is on the outside the body. You need to find out, as in I have told it in the previous video, not right now. Find out what that point is. Okay, mid-sternal line and which one? And some other point. I'm giving one line. I have to give the x-axis. I only told you the y-axis. Find out what it is. Okay, that essentially reflects the average pressure in the arteries. Mean arterial pressure is the average pressure in the arteries during the one cardiac cycle. As a function, it's a time average. It's a time average. Right? There are other ways of finding the mean arterial pressure. Note that the time it takes for a systole is much shorter than the time for a diastole. That is, the heart takes longer to relax than to contract. This is a fundamental physiology principle. I'm not having the time to discuss this. One way to account for the longer duration of the diastole is to take 1/3 of the systolic pressure plus 2/3 of the diastolic pressure to find out the mean arterial pressure. It's a relatively rough formula. Not always going to work. The other is to use this to find the pulse pressure to find out. Pulse pressure is essentially the 1/3 of the difference between the systolic pressure and the diastolic pressure. So these are the various pressures of interest. What are the various ways in which you could measure? The fixed method and dye dilution method and thermal dilution method, some of which we will see in the future classes. Right? I already mentioned the fixed principle. We will discuss that in more detail in the future classes. So with this, we come to the end of this video. In this video, we looked at what is cardiac output and how to measure cardiac output. Why is it critical for health, and how blood pressure and cardiac output are related. I request you one more time to please refresh and review your understanding of cardiovascular physiology, so that you will be in a better position to make instruments that are made to understand the instrumentation behind this. With this, we end this class and we come to the end of this video. We have one more video in this topic in which we will discuss the various methods, which is fixed method, dye dilution method and thermal dilution method.
With this, we end this video. Thank you very much for your attention.